In this video, we're going to focus on naming and writing formulas for oxyacids. Last video, we learned what acids were just briefly. We saw that they were compounds that increase the concentration of H plus in solution, which means they're dissolved in water. In order to illustrate that in their formula, they have the AQ next to it. We saw that for binary acids, there's two elements in it, H and F, or H and a non-metal. Just be careful that it's not O, for example. And if you don't have the AQ, you can't call it the acid. You just have to name it as you would see other types of compounds. So if there's gas next to it, HF would be hydrogen fluoride. If there's AQ, well, then you can call it hydrofluoric acid. And so for binary acids, we saw the prefix hydro in the front to replace the ending of the element with ic, and then we put the word acid. Now we're going to go take a look at oxyacids now. Oxyacids, they also start with an H, but rather than just have two elements in them, like binary acids, they're going to have an H and then a polyatomic ion that contains O. So here we can see H, the polyatomic ion, BRO, and the aqueous, because it still needs to be aqueous to be considered the acid. Now, all over here, we call this bromic acid. There is a bit of an error in the name here. So what I want you to do is, after this video, once you learn all the rules, come back and try to either try to fix the name based on the formula, and then afterwards try to fix the formula based on the name once you learn all these rules. So oxyacids, the first rule I want you to remember is that they do not have the prefix hydro. They still end in ic. Sometimes they can end in us, and they still have the word acid afterwards. So we're going to start off with naming this one over here. So I'm just going to copy this down here, and we're going to focus on naming this acid. So first of all, you need to realize it's not a binary acid, and you know that because of the polyatomic ion that you see here. It's not just two elements like HF or HCl or HI or HBr, for example, H-bromine. So what we do is we have to figure out, well, what is the name of this polyatomic ion? So as you can see, we have NO3, and so you know by now that that should be nitrate. So if your oxyacid contains a polyatomic ion that ends in 8, well, you replace the 8 ending by ic. So this will become nitric. And then what you do is you add the word acid at the end. So this is actually nitric acid. Okay. Now, let's take a look at this acid over here, HNO2AQ. So our first step is to figure out which polyatomic ion we have. So again, recognize that you don't have a binary acid here. You have an oxyacid because it's a polyatomic ion, and we also have the AQ there. So let's take a look at the name of NO2. This would be very useful if you should. It would be very useful for you to review your how to name derived polyatomic ions, because that will be one of the main tricks you're going to be using for naming oxyacids. So if NO2 was nitrate, then one below, sorry, if NO3 was nitrate, then one below NO3, so NO2, must be the ite version. So this must be nitrite. When you have a polyatomic ion in your acid ending in ite, you don't change the ending to ic, you change the ending to OUS. So when it was 8, we changed the ending to ic. When it was ite, we changed the ending to OUS. And then what you do is you add the word acid at the end. So that is nitrous acid. Let's try another example. So let's just move down here. If we had HNO AQ, once again, realize it's not binary. It has a polyatomic ion in it. So we have to figure out what that polyatomic ion is. That's one below the ite version. So this is hyponitrite, hypo, because it's below the ite version. And so because it ends in ite, we're not going to replace it with ic, we're going to replace it with us. So hypo, nitrous, and afterwards what we can do is we can just add the word acid, hyponitrous acid. Rather than move down in terms of oxygen, you could also move up in terms of oxygen. So suppose you had HNO4. This NO4 is one above the 8. So if it's one above the 8, we know it's per nitrate. So you would change the ending of per nitrate to per nitric. Afterwards, you could add the word acid. So that's per nitric acid. So as long as you remember that you have to replace the ending ate by ic and ite by ous, these should be fairly straightforward to name. Remember not to put hydro in the front. So no hydro prefix, because here we have an oxy acid, not a binary acid. And your formula still will require the AQ next to it. So we'll try one more example, and then afterwards we'll learn how to name if you're given a formula. So let's take a look at H3PO3 AQ. So again, your first step is to realize this is not a binary acid, it's an oxy acid. So you have to take a look at what your polyatomic ion is. You have PO3. Since you have PO3, you can probably recognize that this is from PO4, from phosphate, but it's one below PO4. So this is a derivative from the phosphate ion. Let's just make that charge subscript like this, PO4 like this. So if you have PO3, that is one below the PO4. So that would make this phosphite. So we have to change the ending to us. Now, we're not going to call this phosphus. There's a bit of a modification to it, just like you saw with, just like you would see with, for example, sulfur, sulfuric. Phosphus would not work as well as writing phosphorus. So when you have phosphite, change the ending to phosphorus. When you have phosphate, change the ending to phosphoric. So here we have phosphorus acid, phosphorus acid. Not hydrophosphorus, but phosphorus acid. So let's try one more naming. We'll do HClO. So you know that chlorate is ClO3 minus. So 3 is the subscript and minus is the charge. But we're 2 below. So we're not a chlorite, we're at hypochlorite. So this would have to become hypochlorous. And so we have hypochlorous acid. Hypochlorous acid. Okay, so now we're going to take a look at how to name, to write formulas based on the name. So let's say that I had per sulfuric acid. First of all, you know this is not a binary acid because there's no hydro in the front. You know it's an oxy acid. Your first step is to figure out what the formula of the polyatomic ion is. So you need to remember that because there's an ic here, there was an 8 there before because H replaced by ic. So this was per sulfate. To figure out sulfate, you need to remember that this was derived from sulfate. So the per, we know it's one oxygen above sulfate. Sulfate is SO4, 2 minus. That means that per sulfate must have one more oxygen. Superscript. So per sulfate would be SO5, 2 minus. So what you can do now is you can do the crisscross between H and per sulfate. H is +1, per sulfate is SO5. Protect your polyatomic ion, just have the charge on the outside. Crisscross it or charge balance. And you get H2 SO5, and then finally AQ to show that it's dissolved in water and acting as an acid. So here we have persulfuric acid. The same rules apply for any other oxy acid that you see. So to finish off, I'm going to leave you with a thought question. If you have sulfuric acid and hydrosulfuric acid, how can you tell which one is a binary acid and which one is an oxy acid? After you're done describing this, write their formulas down. And then don't forget to go back and see the error in this name or formula.